As we enter into section 1.3, we're going to be looking a lot at angles. So let's take a look at the vocabulary that we need to know to understand our angles. An angle is a figure that's formed by two rays with the same endpoint. With the same endpoint. The same. So if I have an endpoint here, let's call that B, and we have a ray that goes this direction, ray BA, and we have another ray that's ray BC, that is what an angle is comprised of. When we're talking about angles, the vertex of an angle is the shared endpoint or the common endpoint. So that angle that we had before, B is the vertex. The interior of an angle is going to be the set of all points between the sides the sides are those rays that make up the angle of the angle. So it's going to comprise of all the points within this angle, like in here. And that just sort of goes on and on. The exterior of an angle is the set of points outside of the angle. And you could shade that in like this, outside of the angle. Moving on and on and on. In this lesson, we're talking about angles, and when we're talking about the measure of an angle, most of the time here in our class, we're going to be measuring an angle in degrees. And the measure tells us how big the angle is. Or the size. The angles are going to be measured in degrees, and a degree 1 degree is equal to 1 of 360 degrees of a circle. which means that if you have a circle, that circle is 360 degrees. A protractor is a tool that we use to measure angles. We have a protractor postulate that states the following. Given AB, a line, and a point O, on that line AB, all the rays that can be drawn from O can be put into a one-to-one correspondence with the real numbers 0 to 80, 180. So let's draw that line. And then we have O here. Any line or ray that we can create, we can put a protractor on there, and this measure right here that this ray makes is a number from 1 to 1, or from 0 to 180. So if straight line is 180, this might be something like 70. And we can use a protractor to determine that. The measures of our angles can also determine a type of angle. We have 4 types. The first one is going to be the acute angle. The acute angle will measure between 0 and 90 degrees. And less than 90 degrees. And it can look something like the one drawn here. A right angle measures exactly 90 degrees. And we put a mark on that, especially in our sketches, of a little box there to indicate right angle. An obtuse angle measures between 90 degrees and 180 degrees. And can look something like that. A straight angle is just like what its name sounds like. It makes a straight line. It is formed by 2 opposite rays. And it measures 180 degrees. So it looks like a straight line with a dot in the middle. This would be its vertex. We're often going to compare angles. If we say we have congruent angles, those are going to be angles that have the same measure. So if I have these two angles, ABC and angle DEF, I can say, well, we know that the measure of angle ABC, or if I'm told that, is equal to the measure of angle DEF, then I can say that angle ABC is congruent to angle DEF. And on a drawing, if we want to indicate that they are congruent, we put arc marks on them. So I'm going to put an arc here and an arc here. If we have more than one pair of congruent angles, we can also put a, if we have one with one single arc, we can do, and this is a different one, this would be congruent to, as long as the arc marks are similar or the same. The angle addition postulate deals with adding angles. So we've got these angles here, and if S is the interior, or is in the interior, of our angle PQR, then we can say that the measure of angle PQS plus the measure of angle SQR is equal to the measure of angle PQR. When we use this postulate in theorems, we like to abbreviate it though. You'll often see it like angle addition postulate. We learned earlier that a bisector of a segment divides a segment in half. An angle bisector is going to divide an angle in half. So the words that we're going to use to say that is an angle bisector, an angle bisector is a ray that divides an angle into two congruent angles. So our ray JK bisects the angle LJM. And then we can say that angle LJK is congruent to angle KJM.